Hi there, and welcome to our first ever FordCast, a podcast where we take you behind the scenes here at Ford and show you the latest insights and technology that makes our cars go further. Today we'll be looking at EcoBoost technology and our global EcoBoost strategy. Andrew Fraser, Gasoline Powertrain Development Manager, will show you how we pack so much technology into one clean engine. Don't forget to subscribe and stay tuned for our next FordCast. Enjoy.
My name is Andrew Fraser. I'm the manager of the Gasoline Powertrain Development Group for Ford in England, where we've taken lead responsibility for developing the 2-litre and more recently the 1.6 and the 1-litre engine that you can see a model of here. What I'd like to talk to you today is about both some of the detailed technology of EcoBoost, which I'll explain a little bit later on, but also how the 2-litre engine and the whole EcoBoost strategy fit together on a global basis. By now you've probably heard about the One Ford strategy. We've united the Ford operations around the world under Al Mulally since 2006 in a really integrated manner which we haven't achieved before, and this has been particularly true in product development within engineering. For us as powertrain team, this is particularly relevant because we're looking to find powertrain solutions which suit the widest variety of customer needs and requirements around the world, while also making sure that local requirements are still met. One thing that's absolutely common for our customers is concern about both the purchase price of the vehicle and the cost of the fuel that they have to put in it. There's also increasing global concern about CO2, both from customers and governments and other regulatory bodies. For Ford, we absolutely take our environmental commitments seriously, but it's not just about meeting the commitments. We always want to go further and actually exceed the customer's expectations, and that is what we've tried to do with EcoBoost. EcoBoost is all about making engines smaller, more efficient, maintaining the performance and the refinement that customers expect. We live very much in an and society. People want all these benefits of cost, low CO2, etc., but they also want refinement and they want performance. So they're not willing to compromise. Various companies have offered over the years economy models, but they've often required customers to sacrifice on some other attribute, particularly on the performance front. And as a result, they've never been terribly successful. So when we planned this strategy, we recognized that we really had to maintain all of the benefits of the existing powertrains and try and add to those with refinement and greater efficiency. With the EcoBoost, we're looking to offer the customers up to 20% improvement in fuel consumption and a corresponding 20% reduction in CO2. The exact figures vary depending on the precise model, the precise market, but we've moved a large step towards where the high efficiency diesels are, but by using petrol engine technology which suits some of these markets. As I say, fuel efficiency is a key driver for the customers. We have to pay for what you put in the tank. We're seeing here in Australia fuel up around $1.50 a litre, still significantly less than it is in Europe, but rapidly approaching those levels, putting pressure on the consumer every time they fill the tank. Also, people are worried about the environment and they really want to drive down their CO2 footprint whenever they can, but without, as I say, compromising performance or refinement. The EcoBoost rollout began in North America in 2009 with the 3.5-litre V6 twin-turbo engine. It may not sound much like downsizing, but for the North American customer, that was quite a significant step downwards. One of the key, I think, examples of how successful this has been is the deployment of this engine in the F-Series pickup truck. The F-Series traditionally was always occupied by large displacement V8 and even V10 engines up to 6 and more litres. Since the deployment of the 3.5 EcoBoost in 2009, now over 60% of customers are choosing this engine instead of the larger V8 and V10 engines. And I think that's a real proof of the pudding that customers in that traditionally large multi-cylinder engine market are actually voting with their feet and with their wallets to choose the EcoBoost alternative. And that's been a real success for downsizing. Last year in Australia and New Zealand, we launched the Mondeo with the 2-litre EcoBoost powertrain. Compared with the 2.3-litre naturally aspirated engine which came before it, we're offering up to around 16% improved fuel economy, but 26% improvement in power to give the customer a much more exciting driving experience. So downsizing is all about maintaining or even improving power, but significantly improving efficiency and getting lower emissions. As the engines get smaller, a whole series of benefits start to come about. The engines warm up faster, there's less metal, less water to warm up, which is good both for customer comfort and for fuel economy on the cycle and in the real world. We have less moving parts, so there's less friction, less fuel is burned simply moving the engine around. The vehicles get lighter, which improves again performance, and particularly important in the Ford brand DNA, improves the dynamics. You have less weight over the front wheels, so you get nimbler, sportier handling. EcoBoost has 3 core technologies, and we've used these same 3 technologies in slightly different combinations in all 4 of the engine families. The 3.5 litre V6, as I said, primarily in North America, the 2 litre, the 1.6 4-cylinders, and most recently, the 1 litre 3-cylinder, where we've got a nice cutaway model here that you can take a look at. First of these technologies then is turbocharging. This gives us the fundamental ability to shrink the engine displacement by allowing us to pump more air through a smaller engine. And I'll talk a little bit more about that in a moment as we move to some of the exhibits. The second key element is the direct injection. Instead of inducting the fuel into the cylinders with the air through the intake valves, we're now spraying it directly into the combustion chamber at high pressure, giving us great efficiency through mixing of the fuel and air. And then the third key element is twin independent variable cam timing. Both camshafts on the engine can be independently controlled by the engine management system, allowing us to optimize the engine under all conditions. And these 3 elements all combine together in what I like to call a 3-legged stool approach. Each one works with and benefits the other, and the combined package is greater than the sum of the individual parts. So that is a high-level view of our EcoBoost strategy, how we're deploying it around the globe, how we believe it suits a wide variety of different customer requirements and expectations. Now let's go and look at some of the technologies in a little bit more detail. As I mentioned, really the heart of the EcoBoost strategy, the key thing that allows us to downsize the engine is the turbocharger. And we have a cutaway model here. Turbocharging allows us to force more air through a smaller engine, giving the same effect as a much larger displacement engine, but without the fuel economy penalties that we mentioned earlier. Ford has invested a huge amount in turbocharging in the last decade and more. First, really driven by the diesel engine development, where every diesel vehicle on the road now is a turbocharged engine. And I think this has shown that turbochargers can survive in the most demanding high mileage applications. 20 years ago, there may have been some questions about turbocharger durability and reliability, but I think they've now all been answered by the diesels. If you think about the heavy trucks, the big high mileage Intercontinentals that are on the road, they're all big turbo diesels, and they'll run for 1 million miles on one engine. And I think that's an example of how well proven turbocharger technology now is. You can see the turbine on this side, and the compressor which drives the air into the engine on this side. We use very high rotational speeds to allow a large amount of air to be pumped with a very small turbine. With the EcoBoost, we haven't focused exclusively on very high power levels. Rather, we've matched the turbos so that they give a very good low-speed torque response with a very wide operating range, but still with a competitive power level. So that's the short introduction to the turbocharging, the first of the key EcoBoost technologies. Now let's go and look at the second one, which is the direct injection. Second element of our 3-legged stool is the direct injection system. This is a form of common rail injection. We have a single common rail feeding all of the solenoid injectors with fuel at high pressure up to 150 bar. It's then fed to the combustion chambers through these very accurate solenoid injectors, which have a very finely judged pattern of 6 holes in the tip. These spray the fuel into the combustion chamber in a finely defined pattern, and combined with the high pressure, the smaller orifices give exceedingly good atomization and mixing of the fuel, so that literally every drop is burned and we get maximum possible fuel efficiency, power, performance, and very low tailpipe emissions. A further benefit of direct injection is that in some points of the engine operating pattern, we can actually inject more than once per stroke. We do this at certain points to improve smoothness, improve power and torque output, and improve emissions where we are required to. And this is one of the key benefits of direct injection. A third benefit of direct injection is that it cools the air in the cylinders. Because the fuel is now evaporating in the combustion chamber, it draws in heat, the latent heat, to evaporate the fuel. That cools the charge, allows us to get a denser mixture in the cylinder, which is good for power output. And it also helps prevent the engine knocking, which was a traditional problem on turbocharged engines, which direct injection has helped to overcome. The reduction in the knocking means that the engine can have a higher compression ratio, and that helps the efficiency and the fuel consumption of the engine when we're running at part load off boost. So the direct injection is the second key contributor to the overall EcoBoost strategy. Now let's look at the third part, which is the variable cam timing. As I mentioned, each EcoBoost engine features twin independently variable camshaft timing system, camshaft for the exhaust valves and a camshaft for the intake valves on each set of cylinders. And these can be varied by the engine management system through around 50 or 55 degrees of movement, depending on the exact application. This means that we don't have to compromise on the design and operation of the engine. On a traditional engine with fixed camshafts, we had to choose a compromise that gave the best balance of, say, a smooth idle, a good high power output, and most efficient running. But because there was only one fixed set of settings, that was a compromise that didn't suit all operating conditions. Now, with the TI VCT system, we can achieve a near perfect running condition under all operating requirements. For example, at full load, when the driver wants the maximum power or torque output from the engine, we run the two camshafts at a moderate degree of overlap that allows a good amount of air through the engine, through the combustion chamber, and means that the engine can produce a high output, but without requiring too much boost pressure. And that, in turn, has allowed us to keep the turbochargers small and more responsive. So that's part of the systemic benefit. At part load, we retune the camshafts so we get the maximum possible expansion out of the exhaust gas before it flows out of the exhaust ports, and that gives us the best fuel efficiency. Then at idle, we reduce the overlap to 0 or near 0, which gives a very, very stable combustion pattern. That's great for the customer. They feel a very smooth running engine, or don't even feel it when they're sitting idling. And it's also good for tailpipe emissions because the combustion chamber is fully closed and no unburned fuel escapes into the exhaust. So it's a very efficient, very optimized system. A further key benefit of the TI VCT system is it allows us to employ what we call a scavenging strategy to improve the output of the engine at low revs and improve turbo response. I'll explain that further when we look at our fourth model here, which is a section of the cylinder head. This is a section through the cylinder head showing the intake ports on this side, the exhaust ports on that side, with the spark plug and combustion chamber in the middle. And you can see the intake and the exhaust camshaft sitting on the top here to actuate the valve. It also shows quite nicely the high pressure fuel pump, which is driven off a load on the camshaft, providing the high pressure fuel for the rail. Because our engine is turbocharged, the pressure on the intake side is higher than it is on the exhaust side, so we have high pressure, cool, fresh air on the inlet side. If a driver is cruising at, say, 1500 RPM on a light throttle and suddenly wants more output from the engine, for example, to overtake, on a traditional turbocharged engine, when they open the throttle, they would often have noticed quite a significant delay before they got the response they were looking for, and that was known as turbo lag. When we started on the EcoBoost strategy, we recognized that that was a characteristic we really wanted to try and eliminate or minimize as far as possible, and the scavenging solution helps us achieve that. So what happens is when the driver calls for a high output from the engine, the two camshafts are moved by the engine management system simultaneously to give the maximum overlap of the valves. And sometimes we call it the wiper function because the camshafts are moving like the windscreen wipers on the car. So they briefly go to maximum overlap, all commanded by the engine management system. Because we have the high pressure air on the intake side, it flows into the combustion chamber and then straight through out the exhaust ports, which are also open. That flushes the hot exhaust gas from the combustion chamber in what we call the scavenging motion. Doing this gets a cooler, denser charge, more air into the cylinder, allowing more torque to be produced. And it also helps reduce the tendency of the engine to knock, again allowing more torque to be produced. A third benefit of the scavenging is that the increased gas flow goes onto the turbocharger and helps accelerate it more rapidly, which then produces more boost, more airflow going into the engine, and very rapidly you get that positive build-up of torque, which is what the driver is looking for and expecting when they open the throttle. So by combining all these elements together, we've achieved a much, much better and more flexible output from the engine than traditionally a small turbocharged engine could have delivered. And to the customer, it feels much more like a traditional large displacement, naturally aspirated engine. They get that immediacy of response from low RPM, which a smaller engine traditionally would struggle to achieve. And really that is where all of the elements of the EcoBoost strategy come together. The three elements are all required to deliver this. The turbocharging to give the inlet air pressure, the variable camshaft timing system to allow the overlap to be varied at exactly the right point in the operating cycle to give the customer requirements, and then the direct-in-fuel injection, which allows just the fresh air to be drawn through the cylinder, the valves close then before the fuel is injected. If we still had a port-injected engine, that air would also be carrying fuel with it into the exhaust side, which would be bad for fuel economy and emissions. So the EcoBoost has really been built around what I said earlier, this three-legged stool of technologies where each one works with the other in balance, keeping each one optimized, and really producing a sum which is greater than the sum of the parts. So that, I hope, has given you a good picture of how EcoBoost was conceived and developed as a global strategy, and then how the core elements, the turbocharging, the direct injection, and the VCT all work together to give an outstanding driving experience for the customer. That concludes my introduction to the EcoBoost strategy. Thank you very much.